Hello, everyone, and welcome to the December Recreational Astronomy Night Meeting online edition of the RASC Toronto Centre. My name is Paul Markov, coming to you from Markham, Ontario. I'll be your host for this evening. You may be wondering, why are we doing this meeting online tonight as opposed to in person at the Science Centre like we've been doing for the past several months? Well, originally, we were going to combine the annual general meeting with tonight's meeting. But due to circumstances beyond our control, the annual general meeting had to be postponed, and we had already given up our spot at the Ontario Science Centre. So here we are doing the meeting online. We expect to be back live and in person at the Science Centre for the January meeting. As always, I'd like to recognize our top-notch AV team, and tonight that's comprised of Andrew and Betty Reed. Enyo Chalucci, and I think that's all we have tonight. Ward may or may not be able to join us tonight. Now, I'm always on the lookout for presentations. The January meeting is full, and there goes my cell phone at a most inopportune time. I'm always looking for presentations, and the January meeting is full. However, we do have openings at the February 7th meeting. And future meetings also have available slots, and I'm reminded that they occur on the first Wednesday of each month. So tonight's presentations are 4 of them. We typically have 3. However, one of them is relatively short, so we're going to have 4 presentations. The first speaker will be Arnold Brody, presenting the sky this month. Then we have Michael Watson, RASC National President, joining us. He'll talk to us about Chasing the Ring of Fire, October's annual solar eclipse, and other umbral thoughts. Then we have Norm McCall, who presented to us not too long ago. He'll talk to us about the construction of his urban observatory. And then Arushi Nath is back, and she'll talk to us about open source photometry algorithms. From determining physical properties of asteroids to exoplanetary atmospheres. And finally, Tom Luton will close the meeting with announcements and we should be done around 9:30. If you have a question, please enter it in the YouTube channel, and Enyo will ask the question on your behalf to the speaker. And also, if you're watching us for the first time or not, whether you're a member or not, please let us know through the chat box and let us know what part of the world you're from. So let's get a meeting started with Arnold and the sky this month.
Well, thank you, Paul, and hello, everyone near and far. I'm speaking to you from my home in Whitby, Ontario, the traditional territory of Great Mississauga Nations, a subgroup of the Ojibwe Nation. Now, the stars of the familiar Orion constellation represents Bibukeonini, the winter maker to the Ojibwe. His arms reach as far west as Aldebaran in Taurus and east to Canis Minor, ensuring that some part of him is in the sky when we feel his cold breath. The Ojibwe tell us that Bibukeonini was maddened by a duck who paid no attention to his efforts to freeze him out, and he continued to break through the ice to catch fish. The winter maker eventually gave up and retreated north, where it is always cold. The duck teaches us to ignore the cold. Go outside and have some fun. This will madden the winter maker and chase him away whenever he does pay us a visit. Visit nativeskywatchers.com to learn more about the sky lore of the First Nations people and read the stories involving their constellations. Now, the highlights for December includes 4 close passes of planets with the moon: Venus on the 9th, Saturn on the 17th, Neptune extremely close to a first quarter moon on the 19th, and Jupiter on the 22nd. The moon drifts by the Pleiades on the 24th. There is also the peak of the Geminids next week on the 14th. Vesta will be at opposition on the 21st. And the longest night of the year is on the following night, with solstice on the 22nd. There are also 2 double shadow transits on Jupiter at month's end. one for Europe and Africa, and one that favors Toronto and points east. In addition to those highlights, here are some important benefits of observing in December. For example, there's early starts, very long nights, which means we can catch constellations from 3 seasons. The ecliptic is at its highest at night, and that's going to benefit Jupiter, bringing up higher in the sky. And if we ever get rid of the clouds around this area where I am, the dry winter air should translate into transparent skies. And there's one other important benefit of observing in December. There are no mosquitoes. Now, I'd like to include astronomical twilight with night in what I call the observing window, since the planets and bright deep space targets can be observed during astronomical twilight when the sun is at least 12 degrees below the horizon. Now, the window is wide open with 11 and a half hours of night throughout the month. And there's another hour and 10 you can add to that if you want to include astronomical twilight, when the brighter deep space targets and, of course, the planets will be available. Dark skies with little or no moon interference begins tonight with the last quarter moon, which doesn't rise until 1:43 tomorrow morning. And that's leading to new moon on the 12th and the first quarter moon on the 19th. And that gives us deep sky weekends on the 9th, 10th, and the 16th and 17th. The full cold moon lights up the sky between Christmas and New Year's, which adds its beauty to the scene at a time when many of us may be too preoccupied with festivities to do stargazing anyways, so I think the moon picked a good time to rise full on Christmas night. Now let's begin our tour of the night sky with a look at the inner solar system. Mercury during December will swing from east of the sun, briefly visible in the west after sunset, to west of the sun by New Year's, visible in the east before sunrise. Venus spends the month west of the sun as the morning star, and Mars is lost in the sun's glare this December, rising just 50 minutes before the sun by New Year's. It will take months before Mars becomes a reasonable target again. Mercury passed through the greatest elongation east of the sun just days ago. Unfortunately, the ecliptic runs shallow in the evenings near winter solstice, so the little planet is just a few degrees above the horizon after sunset and getting lower each evening. It will pass between Earth and the sun mid-month, and maybe we can catch it rising ahead of the sunrise in the east by New Year's, as suggested here. A much better chance for observing Mercury will be in March, in the evening, when it will be 16 degrees high at sunset. Venus continues as our morning star through December. We'll see it dropping lower each morning. It's on its way behind the sun. The planet has a high albedo of 77% and shines around -4 in magnitude, or -3 due to atmospheric extinction when it gets lower. Here's what Venus would have looked like this morning. With high magnification and steady seeing, you might be able to detect its gibbous phase. Now, as for the outer solar system planets, those giants will be in the south as the sky darkens. Many of our fall favorites will still be visible because of the early sunsets, like Aquarius and Pegasus, flying upside down high overhead. At the start of night, we have Saturn, Neptune, Jupiter, and Uranus lined up, west to east. Catch Saturn right away. It will set in just a few hours, and you'll want to observe it before it gets any lower. If you get above average or excellent seeing, you might catch a glimpse of the Cassini division or Saturn's shadow on the rings. Saturn's rings are tilted only 10 degrees now. We will cross the ring plane in March of 2025. Jupiter still rides high, only a month since opposition, and is getting a boost from the high nighttime ecliptic near solstice in December. It is nearly 47 arcseconds wide and brilliant, with magnitude around -2.7 or a little less through 1.45 air masses. The giant will be due south at 9:20 this coming weekend and visible for 10 hours, which is how long Jupiter takes to rotate. Uranus and Neptune round out the outer solar system giants. Uranus just passed opposition last month as well, and is bright enough to be spotted by eyes alone on a night with above average or excellent transparency. Use binoculars to locate Uranus, which you can't mistake as a star because of its blue color and a disk shape. Once you've memorized a couple of nearby stars, drop the binos without moving your eyes and see if you can spot the blue dot. It's doable. Neptune will require binos or a telescope, however. It's the only planet that cannot be seen by naked eye. It also has a blue tint and a tiny disk, just a couple of arcseconds wide. Now, while we're in the vicinity, high in the southeast, about 20 degrees northwest of Jupiter, is the Triangulum Galaxy, M33, sometimes overlooked with the Andromeda Galaxy right next door. You can find the face-on spiral about 1/3 of the way between Alpha Trianguli and Sigma Piscium. Messier 33, also known as NGC 598, is home to 40 billion stars. And that makes it the third largest member of the local group after our Milky Way with 200 to 400 billion stars, and Andromeda Galaxy pegged at 1 trillion. M33 is 3 million light years away, putting it slightly behind M31 from our viewpoint. Those two galaxies are merging. Andromeda has pulled a long trail of stars out of M33, and that trail now extends between them. Andromeda will completely swallow M33 in about 2 billion years, just prior to Andromeda's merger with our Milky Way, so we're all coming together. The galaxy's disk is inclined by 54 degrees, giving us a good view of its loose spiral arms emerging from the center without a bar. There is no bulge in the center. Large amateur scopes and astro images will show numerous H2 regions which have NGC designations and possibly some globular clusters. These are massive O-class and intensely hot Wolf-Rayet stars that are triggering the H2 emissions. Now, this is a good time to observe M33, sitting just 15 degrees from the zenith early in the night. Observing the outer planets and M33 will give Orion and the Gemini twins a chance to rise in the east. Here's the scene around 9:15 with the Perseus arm of the Milky Way peppered with open clusters, rising up from Monoceros and passing through the feet of the Gemini twins, Orion's raised arm, and Auriga. There are so many targets, so where to begin? Well, let's begin at the horizon and pick out a few targets on our way up. We start with the seasonal favorite, NGC 2264, which is the designation for two objects, the Christmas tree cluster and the Cone Nebula. You will find this duo about 4 degrees southeast of Xi Geminorum, the eastern foot of Pollux. The cluster is naked eye bright and a great binocular target, stretching 20 arc minutes in height. The tree is lit up with massive OB stars, making the cluster especially luminous from over 2,000 light years away. Compare with the Pleiades, which is just 440 light years distant. The Cone Nebula is a massive dust and gas cloud sculpted by the stellar winds from the Christmas tree stars and silhouetted by the H2 region behind it. It may be old hat, but it's difficult to overlook the Orion Nebula, and I hope you'll forgive me for making a stop here. When observing M42 in Orion's sword, you'll also see M43, the comma-shaped emission nebula sitting alongside. This is the closest star-forming region to Earth at 1,350 light years away. Now, with significant magnification, you can split the four stars of the trapezium cluster in the heart of the Orion Nebula, and it was first discovered by Galileo. With 125 millimeter or larger telescopes, you may resolve up to 6 stars. Many of these stars are spectroscopic binaries. Collectively, their winds have blown a hole in the molecular cloud from where they were born, allowing us to peer in. Research astronomers are studying these newborn stars and the infrared signatures of protoplanetary disks surrounding them. These may be the newest stars you'll ever observe, estimated to be only 300,000 light years old. OB stars live for only several million years, like 5 or 10, before they blow. M43, discovered by the French scientist Jean-Jacques Autors du Marion around 1730, is illuminated by O-class spectroscopic binary star, the one right here, the hottest of the main sequence stars. And the M42 and 43 components are members of the same molecular cloud, separated by a dust lane known as the M43 dark lane here. And together, these clouds are part of the much larger Orion molecular cloud complex, which stretches the length of the host constellation. Next on our tour is a trio of bright open clusters in the southern half of Auriga that are often referenced together. Charles Messier added the trio of M36, 37, and 38 to his catalog in 1764, but the trio of clusters were first discovered 100 years earlier in 1654 by Giovanni Battista Hodierna using a simple Galilean telescope operating at only 20x. The clusters were then independently rediscovered a century later by Guillaume de Gentil and Messier for inclusion in Messier's catalog. Now, according to Robert Trumpler's classification for open clusters, he considered M37 to be strongly concentrated. That's the Roman numeral 1 here, meaning strongly concentrated. And he considered M36 to be not quite so concentrated, although it does look pretty tight to me. So he assigned it Roman numeral 2, and the least of the three in terms of concentration would be M38, this fellow here, with classification 3. And all of these three clusters, they're at the same distance from us. So the first two are 4,240 light years away, and M37 a bit further at 4511. The stars of M38 add up to a magnitude of 6.4, whereas M36 at the same distance is 35% brighter because it has a lot of bright stars in its core. Brighter still is M37. Its magnitude 5.6 because it's very rich. It's got like 500 stars in it, many of them quite bright. And it's convenient that these three clusters are right next to each other, so it's easy to go back and forth between them to compare their differences. All right. Continuing our climb up into the eastern sky, we reach Beta Persei, known as Algol, the demon star. The star has been despised for millennia by the ancients because it visibly dims by 75% every 2.86 days, from a bright 2.1 to a noticeably dimmer magnitude 3.4. And that happens in a matter of hours. Excuse me. Since all stars were considered unchanging, everlasting and perfect like divinity, the pulsing of Algol's light was considered wrong and evil, and depicted, for example, as the head of Medusa in Greco-Roman mythology. Algol is a bright binary star with its orbital plane almost perfectly on our line of sight. Larger but dimmer Algol B blocks most of the light from A when it passes in front, causing the noticeable drop in light. There is a secondary dip when B goes behind A, but we cannot notice that one visually. Perseus rides high in the sky in winter, so there will be opportunities to watch it dim or re-brighten over the course of an observing session. There will be an excellent opportunity on Thursday, December the 14th in the Eastern time zone. Mid-eclipse occurs around 9:30 that night, which means you can watch it beginning to dim at the start of nightfall at 6:30, or you can watch it re-brighten around 10:30 if you are out late that night. Now, there is a comet well placed for observing from the northern hemisphere this month. It's comet 62P Su-Shinshan, which glides through Leo in December. Leo will be rising around or before midnight over the next month, which puts the comet 56 degrees away from the sun and easy to follow. The comet is not expected to reach naked eye visibility. The most optimistic estimate I saw said it would reach magnitude 8 at perigee in mid-January, so it's not naked eye bright, but an easy target for binoculars and cameras. The comet has a 6.18-year period that has its perihelion point just outside Earth's orbit. In other words, it comes closer to Earth than it does to the sun. We will have ringside seats for 62P's next pass as it reaches perigee in mid-January at a distance of only 0.4 AU. Turning our attention to the sun now, there was a large coronal hole on the sun that was Earth-facing last Saturday and through which strong solar winds escaped, reaching Earth 2 days ago. And as the hole rotates away, we can see magnificent loops and prominences around the sun's limb and bright active regions that rotate into view. The active regions are progressing closer to the sun's equator, and that's a sign that solar cycle 25 is approaching sunspot maximum. The monthly sunspot counts for the current cycle have matched the predictions made by a team led by Scott McIntosh, an astrophysicist at the U.S. National Center for Atmospheric Research. His technique involved up to 4 magnetic bands rotating below the sun's surface that he says were going to align, at least to some extent, and that would strengthen the sunspot activity and cause it to peak a year earlier than those predicted by the NOAA NASA team. McIntosh says it will predict around April in 2024, and that would be right in time for the total solar eclipse. Imagine the huge, wide, large-reaching wild corona stretching in all directions around the black disk of the moon. That should be awesome. And speaking of the moon, here we see its phases and libration for the rest of December. Perigee will be on the 16th with the moon a young crescent. The southeast limb of the full moon tilts her way at month's end. And on January 1st, the moon is at apogee, appearing about 9% smaller than it did at perigee. On Saturday, December 16, a 4-day-old crescent moon is available for observing for a few hours after sunset. And this is an opportunity to explore differences between the Gang of Four craters, Langrenus, Vendelinus, Petavius, and Furnarius, that are not far from the moon's south to southeast limb. The 4 craters range from 125 to 177 kilometers in width, and 2 of the 4, Langrenus and Petavius, have well-defined sharp terraced walls and significant central peaks, while Vendelinus and Furnarius are heavily worn and without central features. Now, if you can catch this Gang of Four the night before, on Friday the 13th, the terminator will be much closer to them, and the central peaks in Langrenus and Petavius will cast long shadows, helping them to stand out. Let's have a look at the December highlights now. This coming Saturday morning in the east, there will be a lovely pairing of the gibbous Venus and an old crescent moon. The Geminid meteor shower peaks on Thursday morning, December 14. The Geminids have become the best meteor shower of the year with a predicted zenith hourly rate of 120 under ideal conditions. And that surpasses the popular Perseids of August. This year, a one-day-old moon sets during twilight on Wednesday the 13th before the radiant next to Castor even has a chance to rise. So there will be no moon interference all night long. And that's perfect. The peak happens as the radiant transits the meridian around 2:30 local time in all time zones. Now, the Geminids are unusual in a couple of ways. First, the Geminids only became an observable shower in the early 1860s, with a ZH hour of only 14 or so, plus the occasional fireballs. Now, the rate steadily grew throughout the 20th century, up to 50 by 1930, 60 10 years later, 80 by century's end, and now predicted to exceed well over 100. Now, the second oddity is the influence Jupiter's having on the Geminids. Jupiter's pulling on the stream, causing it to sweep past Earth's orbit, accounting for the ZHR climbing since the 1860s, when Earth first crossed it. The sweeping outward pull by Jupiter will continue on the stream until Earth no longer crosses it in about 80 years, and the Geminids will end. The orbital path of the Geminids crosses Mercury's orbit and reaches out beyond Mars, crossing Earth's orbit, where we pass through in December. Astronomers searched for a comet in this path without luck, until finally an asteroid or an extinct comet was discovered in 1983 using images taken by the infrared IRIS satellite. This is an image taken by the Arecibo observatory that we've lost. Now, the orbital elements are the same as the Geminids meteor stream. So Pantheon was determined to be the parent body of the Geminids. But mysteries remain. Observation by the stereo spacecraft during perihelion show that Phaethon brightening and producing a tail, but there is very little dust in the tail. It's mostly vaporized sodium gas. The particles we currently pass through must have been produced in some breakup in the past, but it's really just a mystery at the moment. The Japanese Space Agency is planning Destiny Plus, a mission to send a dust-analyzing spacecraft to fly by the rock comet, with launch in 2025 and flyby within 500 kilometers of Phaethon 4 years later. The spacecraft will have a dust analyzer, a telescopic camera, and a multiband camera, and maybe it'll help answer some of the riddles. On Sunday, December 17th, Saturn sits 2.5 degrees north of the crescent moon. 2 nights later, Neptune comes within 1.3 degrees of the moon for observers in Asia-Pacific region, that is. By the time the duo are visible from Toronto, the separation will have grown to 5 degrees. Asteroid 4 Vesta reaches opposition on Thursday, the 21st. It can be found 1/3 of a degree east-northeast of Chi 1 Orionis, at the top of the Hunter's Raised Club. Just at or below the cusp of naked eye visibility, Vesta will be easy to spot in binos or a telescope. You could monitor its retrograde movement against the background stars throughout the night. The moon drifts within 3 degrees of Jupiter on the night of Friday, December 22nd, again favoring our astronomy friends in Asia Pacific. The two will be twice as far by the time they rise over Toronto, twice as far apart. There will be a double shadow transit across Jupiter visible from Europe and Africa on Saturday night, December 23rd. Ganymede's shadow will be a large smudge near Jupiter's south pole, while Europa's sharper shadow will transit across a brighter band and should be more easily seen. Here we see it popping onto the brighter band. And that might be easier to spot than Ganymede's shadow. Early in the morning on Sunday, December 24, a nearly full moon glides within a degree of the Pleiades and should make for a sparkling scene. You may want to try a moon filter to help give the stars of the Pleiades a chance to shine through the glare. And 1 week after Ganymede and Europa cast their shadows together on Jupiter, they do it again. This time it favors observers in Toronto and east. Further west, and there will be more twilight to deal with at the start, but it's still worth a try. The two shadows transit side by side as the sky darkens, and there's a bonus too. Just as Europa's shadow is about to leave Jupiter's cloud tops, Io reemerges from Jupiter's own shadow on the other side and pops into view and back into the sunlight. In real time, you can watch Io grow from a pinprick of light to its full illumination over a couple of minutes. And that's all I've got for tonight. Are there any questions?
Well, first of all, thank you very much, Arnold, for a very thorough and enjoyable presentation about the sky this month. You have some fabulous graphics there. You'll have to tell us where we can find all that one day.
Well, those are my trade secrets.
Indeed. All right, let's talk to Ennio. Do we have any questions, Ennio, for Arnold?
We have no questions, but I would agree. Those are fantastic graphics.
Well, thank you.
Yes. All right. Well, thanks again, Arnold. Until next time. Good. So let's move on to our next presentation then. And it's Michael Watson, who is our RASC national president. And I think he became national president fairly recently, a few months ago. And I was really hoping to have him in person, present in person, but here we are online this evening, unfortunately. Maybe we'll get him down to say hello in person next time. So Michael will talk to us about Chasing the Ring of Fire, October's annual solar eclipse, and other umbral thoughts. Take it away, Michael.
Everybody, can you hear me? And can you see my screen? All right, so I'm on. Hello, everybody, and it's a real pleasure always to speak to the Toronto Centre. Last time it was in January, and this time is actually fairly propitious because we are about 1/3 of the way from the annular solar eclipse in October that this little presentation is about to the great April 8th, 2024 eclipse, the second great American eclipse. The first one I think many of us will remember, many of you probably attended and viewed, was in August of 2017. It was just unbelievable. I remember at the time, and you'll see some photographs of this a little bit later, thinking that it was such a long time until the second great American eclipse almost 7 years later. And here we are just within a few months of it. So this is my first time speaking to the Toronto Centre as national president of the RASC. For those of you who don't know me, I am now in my 53rd year as a member of the RASC, and I think that I am probably the oldest president of the RASC in the last century. So here we go. We're talking about the October. I actually got this put this wrong in Photoshop when I put in the 10th. It was actually on the 14th, and all the rest of the slides I think are correct. And so these are some other umbral thoughts as well, including, of course, the April 2024 eclipse. So just to remind us all about this. This is from Fred Aspanak, probably the world's greatest eclipse predictor, and a friend of mine from a long time ago, and that shows the elliptical orbit of the moon, which is responsible for producing the difference between total and annular solar eclipses. And so we see here, and I hope that, I'm not sure whether you can see my cursor. I'm not going to move that, but what you can see is our dotted lines and arrows going toward the lower right. Those are the so-called lines of the apses, and those lines are sort of on the axis between the apogee point of the moon, the furthest distance from Earth in its orbital motion, and the perigee point, the closest point. And what we can see here is that where the moon reaches close to the perigee point, where it's closest to Earth, a total eclipse of the sun can occur. 6 months later, approximately 6 months later, when Earth is on the other side of the sun, the line of the apsides is still in approximately the same direction. And what that means is that at new moon, the moon is near apogee, and therefore it is too small to cover the bright surface of the sun completely, and we see a thin annulus or ring of sunlight around the dark disk of the moon. And this is one of the most amazing coincidences of nature, and that is that the sun is approximately 400 times the diameter of the moon. It also lies almost exactly 400 times as far away from Earth as does the moon, and therefore the two of them seem to be approximately the same size in the sky. However, because of the elliptical orbit of the moon around the sun, actually more properly around the Earth and the moon actually revolve around a common center of gravity, but we think about it as the moon revolving around Earth. Because of the elliptical orbit at apogee, the moon is too far away to cover the sun completely. Now, most people don't travel long distances to see an annular eclipse of the sun, and the reason is that an eclipse such as that, you cannot see the solar corona. That is reserved for total solar eclipses, as we will see. And so what we see here is the geometry of an annular eclipse, where the moon is too far away to have the umbral shadow, you can see it says umbra there, actually reach Earth. What we see then is the so-called anti-umbra, where if you're located within the region on Earth where that is projected, you can see the moon passing centrally across the disk of the sun, but again, an annulus or ring of sun is left unobscured, as compared with a total eclipse where the moon, as you can see, again, not to scale obviously, where the moon is closer to Earth and the umbra of the moon's shadow touches Earth and crosses Earth in a band of just a few kilometers to about 200 kilometers in width. So we have these various different kinds of eclipses, and just to choose some by Fred Esmenac. A partial solar eclipse. Almost everybody has seen one of those using, of course, proper solar filters. Then we have an annular solar eclipse. This was again from Fred, and that's what it looks like through a solar filter. And of course, a total eclipse of the sun. So I'll try use some of mine, which aren't, I think, nearly as technically good as Fred's. But we will see then a partial solar eclipse. This was in 2013, shot from the shore of Lake Ontario in November. It was very cold. The sun, as you can see, was oblate. It was only about 2 degrees above the eastern horizon. And I took a telescope down and managed to get a photograph of a very small partial eclipse just before it ended. Then in Muskoka 2014 with a 400 millimeter telephoto lens, this time just before sunset. They can be really very pretty affairs. This one I got in May of 1994 in Ohio. I'll be talking about that a little bit later. And then this one I think that we will remember, and this was back in 2021 when there was an annular eclipse of the sun that was visible as annular only in northern Ontario, far north Ontario, and then going off to the north across Hudson's Bay. It was a very large partial eclipse as seen from Toronto area, and this was the eclipsed sun just after sunrise, again from the shore of Lake Ontario, just east of Toronto. And this was a total eclipse of the sun back in the old film days, back in 1999, shot from just north of Paris in France. So I think it's really interesting, and some of you have seen these few slides before, to take a look at and appreciate the eclipses that are visible, the so-called central eclipses. That is where the moon passes centrally across the sun, in either a total eclipse or an annular eclipse. Those are all central eclipses. And what I did is I put together a number of these from 1963 to 2024. And what we can see here then, North America, I'm going to show the total eclipses in red and the annular eclipses in yellow, and they're all in chronological order. And so in 1963, July 20th, I did not see this one. I was only 10 years old at the time, but a lot of people saw this eclipse, and it passed just, well, very near Quebec City, and was the first one in a long time to be visible from populated parts of Canada. In March of 1970, a very celebrated eclipse up the eastern seaboard of the U.S., probably the most widely observed total eclipse of the sun that had been seen to that point in time, because of the populated areas that it crossed. Then in 1972, an eclipse that almost paralleled the 1963 eclipse and crossed Prince Edward Island. Somebody should have written a song about that. Oh, I guess maybe somebody did. And then in 1979, a lot of people saw this eclipse in February, which came across the Pacific, entered the U.S., and then curved north over Manitoba. Members of the Toronto Centre, this was the first eclipse expedition that I had ever organized. We organized 2 aircraft to fly to Gimli, Manitoba to see that eclipse, and we were successful in very cold conditions. The late, wonderful Terry Dickinson was on that trip, and it was the first eclipse that he had ever seen, total eclipse. Then in 1984, there was a very thin annular eclipse, which we saw from North Carolina. 1991, the Great Long Eclipse, a 6-minute eclipse that crossed Baja California. This time we chartered a jet aircraft to fly us down to see that eclipse, again, very successful. 1992, there was an annular eclipse of the sun that ended just off Catalina Island at sunset. We went to see that one, but we were clouded out, which was a real shame. And then the one I'm going to tell you about, a very long eclipse, 6 minutes in May of 1994, another annular eclipse. This is the one that so many of us remember from August of 2017, the first great American eclipse, as the website says, and as people talked about in the US. Again, at that point in time, then 2017, this was, I think, without a doubt, the most widely observed solar eclipse, certainly among people who actually wanted to travel to see it. Then the June 2021 eclipse that I just mentioned, the path of annularity just off Lake Superior and going north. And then this past October, again, the 14th, I should have put that in correctly, in October. I'm going to tell you about that one because that's the one that I went to see. And then finally, we have in April the 2024 eclipse that many of us are going to be traveling to see. And I expect maybe everybody who is listening to this is going to make an effort to see, because the path of totality crosses parts of Ontario and then Quebec. It's very close, although the weather prospects are somewhat dicey because it's really a sort of meteorologically a shoulder period of the year where we still can expect a lot of cloud and sometimes even snow at that time of the year. Okay, so moving on then, I just want to go back then to 1994 because this was the first annular eclipse that I had ever seen. And I thought that it was just a wonderful opportunity because the path of annularity, as you can see, passed over Toronto. It actually turned out to be clear that day, but I wanted to go to the center line right near the point of maximum eclipse. And so here is where I was, and that was right at the point point of maximum eclipse. And as you can see, the duration of annularity there was 6 minutes, 6 minutes 2 seconds. The sun was very high in the sky. It was very clear, and it was just after noon Central Time. I had arranged with my, as I said, my old friend Fred Aspanak, who was still working at the Goddard Space Flight Center, doing eclipse predictions and various other works, to meet up with him. I drove my mother down to see this one because she hadn't seen it, and Fred and his wife joined us as well. And so a long time ago, here I was with some older equipment. This was a 5-inch astrophysics refractor, first one actually that came into Canada. After it started being built, with an old film camera, and we see here not great photos. This was my first time trying to do something like this. Obviously, I managed to photograph this not exactly at the moment of maximum eclipse. It's just slightly off-centered. I think I did better 2 months ago, but we'll see. And then toward the end of annularity, and you can see then that the mountains on the edge of the moon at the left are now just starting to break up the annulus of the sun's surface. And there we are, Fred and his wife and my mother and me, with all of our equipment in Western Ohio. So that was a really great event. Obviously, no corona scene, but a really terrific event. And so now, just coming forward now to 2017 and 2024, and then what we have just seen, these are then the two great American eclipses. You can see that the paths intersect in Missouri and Kentucky. There's a little area there where these paths cross, and people have the opportunity then within a 7-year period to see two total eclipses of the sun, which is quite unusual. And the weather actually in August of 2017 was quite good, so people in that area did actually manage to see it. And then we add in the annular eclipse, and so this is the one that I'm going to talk about and show you a few photographs of. And you can see that it crossed Texas and New Mexico. And so the places I had months and months ago decided that I was going to try to see this in October. And the first place that I wanted to try to go to see it from was Corpus Christi in Texas. A few days before the eclipse, it looked as though the weather was going to turn really bad in Corpus Christi, but it looked as though the area around Roswell, New Mexico, of all places, would clear up. And so that turned, I changed my destination to there. 2 nights before the eclipse, when I got to Tulsa, Oklahoma, it appeared that Roswell was going to be clouded out as well, but there would be a big opening in the clouds over western Texas. And so I changed plans again and then went to Midland. And so you can see from Midland there, the duration of the totality was 4 minutes 50, or annularity was 4 minutes 56 seconds, sun up, reasonably high in the sky. And so that was the idea. And this was my trip. For those of you who read the Journal of the RASC, my president's message in the current edition is about that. And because of various court hearings that I was involved in, I had only 5 days to do this entire trip. I left shortly after my hearings were over on the Wednesday night, drove like crazy, 2,800 kilometers over the course of essentially 2 days to get to Midland, Texas, and then see the eclipse in return. So here we are, starting on the Wednesday night, crossing, and this is about, 8 o'clock at night, crossing the Ambassador Bridge to get into the United States. Drove about 600 kilometers that night and arrived at around 11 p.m. in Fort Wayne, Indiana, where I stayed overnight. And then the next morning, up nice and early, because it was a 1,200 kilometer drive to Tulsa, Oklahoma. So I was on the road. It's really easy to figure out where you are. It's easy to see that you're in the United States almost as soon as you get there. And so, among other things, the speed limit increases, but you also see things for sale that you don't see quite as much in Canada. So here I am on the road, Getting into Oklahoma, you can see there on the left, the speed limit goes up more. It's great for driving if you like going west in the U.S. because the speed limit, as soon as you cross the Mississippi River around St. Louis, increases. Yeah, this is something you don't see all that often in Canada as well, but here we are. And then into Texas. Drive friendly, the Texas way. And the President George W. Bush Bridge. Big name in Texas, as you will see. One of the things that's really interesting there when you're in Texas is it's a huge cotton growing state, as I think you probably know. What I didn't know is that there's a second crop that's planted in September and it's harvested in December. So this was October and the cotton was just coming out. And beef feedlots all over Texas, as you might imagine. This is something also you don't see so often in Canada, and that was worth a stop and a photo. One of the things I have to say, the Texans were incredibly hospitable and incredibly friendly, and also amazed that a Canadian had driven all this distance to see this thing. So the city of Midland, Texas, 100,000 population. It's really an oil servicing city with a long history. It was very interesting to see. This is where I stayed, had just one night. And then on eclipse morning, this in fact was eclipse morning. It was really nice and clear as the weather forecast had said. When I got up, it was 9 degrees Celsius, really quite cool, but that was fine. I didn't mind at all. In the and the traditional Bush family home where they first lived actually happens to be in Midland, and there it is, where George W. Bush was born. Anyway, eclipse morning, there's Venus looking east, the sun's going to rise, and there's going to be an eclipse. And so people, I scouted out and found a number of sites, got to a really nice park there. People came from Florida, from Michigan, from Oklahoma, from California to see this, and it was just really terrific. Here were a couple of guys from one of the universities in Texas with their equipment, and here I am getting set up with a telescope and my smaller mount. It's a portable mount, Skywatcher mount that I take around and has been to Australia, for example, for astrophotography. And it was a pretty big deal there. Eclipse T-shirts and the planetarium in Midland had speakers, including the first Native American NASA astronaut who was speaking that day. So here we are, waiting for the eclipse to start. And so these are the solar filters that I use. I think a lot of you will be very familiar with them. I've been using them for years, and they're wonderful. And so that's what the sun looks like through a Kendrick solar filter. No, most people are used to seeing the sun as a yellow disk, but that's actually artificial coloring through filters. This is what it actually looks like. A Kendrick solar filter does not change the color balance at all. That is the true color of the sun. And so here we go. This was just before the start of the annular eclipse. You can see there's some sunspots on the surface of the sun. And then just 86 seconds after the start of the eclipse, you can see the moon starting to encroach on the right side. And I know that over the course of the next hour or so, it's going to move across, as we can see, 29 minutes after the start of the eclipse. And then I got one just as it was engulfing a sunspot. And you can actually see there the mountains on the edge of the moon. So this is an hour and a bit after the start of the eclipse. All right, and then we get very close to the start of annularity. This is really exciting. It was great to see, and actually just to look up with no binoculars or anything, but just glasses to see this incredible sight in the sky. It was just amazing. And then mid-eclipse. And so what this shows is, first of all, I got the timing right this time, but also second, I was very, very close to the center line. If I had been off the center line an appreciable distance, the dark disk of the moon would have been displaced by parallax north or south. But here you can see that I was really, really close to the center line. And There we see then a magnified view, and you can see actually mountains on the limb or the edge of the moon there over the solar disk right at mid-eclipse. And then finally, the end of annularity with mountains on the edge of the moon starting to break up the annulus of the eclipse. And then moving off. So a little collage of the 3 photos there, and we can see the timing, central time, sun altitude at 42 degrees, and the amount of the sun's disk that was covered at this annular eclipse. It was pretty spectacular. Now, so we've got then the annular eclipse. It was a terrific trip, and I managed actually to get back in time for my next hearings in court. So it was a very successful trip, 5,800 kilometers in 5 days, and I'm just so glad that I saw it, and I was very lucky to have really good weather. And so now what we have, of course, we have then just looking forward, we have the 2017 eclipse, and what I thought I would do, because we were all looking forward to the 2024 eclipse, and some of you who may be interested in traveling to see the 2024 eclipse may wonder whether it's worthwhile and what it actually looks like. So I'm just going to show you a few photographs that some members of the Toronto Centre have seen previously from the 2017 eclipse. And so my entire family drove in 2 vehicles from Toronto to where we had planned to see the eclipse, Grand Island, Nebraska. 1,800 kilometers, which wasn't bad. It was a day and a half. And what ended up happening is that because the clouds were starting to come in and the weather forecast didn't look good, on eclipse morning, we got up at 3 a.m. and then drove 540 kilometers, as you can see, to western Nebraska, where it appeared that it would be clearer. The entire drive there to Scotts Bluff there was dense fog, but I thought it would probably burn off. And just as we arrived at Scotts Bluff, it did burn off. And this one was the clearest and best of the 9 total eclipses that I had seen to that point. And so here we are set up north of Scotts Bluff. A lot of people were there, set up on top of that pile of gravel. I had brought 2 telescopes, well, actually 3. One on my big mount to photograph, and then this one to let people see. So this was during the partial phase of the eclipse, and there was my equipment set up. Pretty exciting. And just before the start of the eclipse, again, a lot of sunspots. And the start of the eclipse, the advancing moon, you can see mountains on the edge of the moon there. And I like this photo. A lot of wisps, a lot of structure in the corona. I was very pleased to be able to get this one. This one is something that's really interesting and that you don't see very often. With a really good telescope and clean optics, if you take a long exposure, you can see that the corona just burns out the outside of it, but you can actually get earth shine at mid-eclipse. And you can see the mountains, highlands, and so-called seas, the Maria of the moon. It takes some practice and some processing to do this. I was hoping to get it, and I did. And then at third contact, just at the end of the eclipse, you can see the first Baily's beads coming through, but prominence is on the edge of the moon, and that is the color. That is not enhanced color at all. That's what it looks like. Really spectacular. And then the diamond ring at the beginning of the eclipse, and then at the end of the eclipse. 39 seconds after the end of totality, people say, "Oh, don't look at the sun," and so on. As soon as it's third contact, in my experience, you can look at it through a telescope, naked eye, very, very briefly through a telescope, up to about 30 seconds or so after the end of the eclipse. And here we can see then that it's as it says 39 seconds after the end of totality, the brilliant light of the sun. There's no solar filter on this, obviously, and we can still see some prominences and some of the chromosphere. And there we go. So a successful trip, and that's what you can see. And so I hope that people will make the effort to see the eclipse in April. We plan to be, well, there are 3 observing sites that we have set out. One, actually, the weather prospects look fairly good for the south shore of Lake Erie, just west of Cleveland. We also have observing sites in the Quad State area near St. Louis, but we're probably going to end up being in Texas, and I have a number of observing sites set up there, along with reservations, and we're really looking forward to that. So that's my half hour. And I thank you very much, and I hope that everybody is, well, first of all, enjoyed this and is going to make an effort to see the eclipse.
Thank you very much, Michael. Appreciate you presenting this to us. You sure like driving, don't you?
Well, I'll do it. I'll do it.
Amazing. Very good. All right. Do we have any questions for Michael?
So we don't have any questions, but we do have an interesting chat going on in YouTube. I'll start with Eric Briggs. March 7th, 1970. The total eclipse was visible from the eastern seaboard less than 6 weeks before Apollo 13. Tariq Alhamrani writes, "Hi Al, I just got back into astrophotography and I started with solar imaging, so I hope to keep going. I stopped for nearly 2 years, or say 1 year, as I tried solar imaging last year but then stopped." Guy Yanis follows with, "I saw that partial in 1979. Did not get to see totality." Eric then says, "At a glance, I think none of these central eclipses were from the same Saros." Stuart Stein says, "I'm flying to Austin to see the 2024 eclipse. Don't want to take a chance, or less of a chance, on being clouded out." Just a moment, please.
These are all great comments.
Eric Briggs says the George W. Bush childhood home is one of the tourist features in Midland, Texas. R.A.S.C. Toronto, who I believe is Betty, "I saw the 1979 solar eclipse in Winnipeg and can assure you that it was pleasant, sunny day, relatively speaking. The cold can be quite bone-chilling in that region." Guy then says, "Wow, must have been a nice spectacle in Winnipeg." Betty then says, "Seeing the corner was amazing. It would have been hard to describe how beautiful it is." Stuart says, "Wow." Guy Yanis says, "Indeed, totality brings the whole experience to a different level. The corner is an eye-watering experience. I was lucky enough to catch totality at La Higuera in Chile in 2019. Pardon me. Plus, the birds stopped singing even midday in the middle of winter. Northern Chile would be ideal for an eclipse, with the Atacama Desert and the clear skies." Deanna says, "That was very motivational." Atul Dave says, "Great photos and great presentation." Stuart writes, "Where in Texas are you observing in 2024? Ron McNaughton says, "Any pictures of shadow bands?" Guy Yanis now writes, "Nice presentation. I will do my best in Sherbrooke in April." Atul then says, "What about April 2024? What are your suggestions?" And that's everything. So a couple questions were sneaked in at the end.
Sure. Well, listen, thank you very much for reading those. That's fantastic. And what it certainly demonstrates is that there are a lot of people who've seen a lot of eclipses. It's interesting, the one for Winnipeg, and I'll get to the questions in just a moment. I'll just take a couple of minutes here because I know you've got another presentation. But we were in Gimli, Manitoba, which is very close to Winnipeg, for the February 26, 1979 eclipse. And what I remember is that there was some cirrus cloud in the sky. That actually, now it didn't really impair the view, but what was really interesting is that with the cirrus cloud, you could actually see the dark shadow of the moon approaching from the west, racing across on the cirrus cloud. And you knew that when the edge of it then touch the sun, that then would be the beginning of totality. So it was really just absolutely fantastic. Question about Texas and observing sites. One of the places I'm not going to tell you exactly where I'm going to be because we've scouted these out, but there are several places, and one is on a highway that runs from Austin, Texas, up to the little town of Llano, Llano, which is just off the center line. I've got a number of spots there, then some up closer to Dallas, Fort Worth, and so on, and San Antonio. And so, because we just don't know, first of all, what the crowds are going to be like, and we don't know what the weather is going to be like. I've got several sites, very, very specific sites set up, and also in Cleveland. You just have to have backups, and you have to be ready to go. And so what we're going to do, and this is the tip for everybody, if you are prepared to take, a few days off work because it's a Monday eclipse, and if you're prepared to do some driving, then what we're going to do is, and this includes Randy Atwood, director and former president of the RASC, has been a longtime friend of mine, and his wife Betty, and my wife Helen and I, we're going to be driving in two separate vehicles because I got a lot of gear to carry to St. Louis on the Friday night. Eclipse on Monday. We're going to drive to St. Louis on the Friday night, and then overnight on Friday, we are going to decide, based on the weather forecast then, are we going to go back up, retrace our steps up to Cleveland? Are we going to stay in the Quad State area, or are we going to go on for another day or so driving, a day and a half to Texas? And you got to do that. Particularly with the really iffy weather prospects for that time of year. And if you want to find out about that, go onto the Eclipsophile website of Canadian astronomer and meteorologist Jay Anderson, the foremost weather forecaster for eclipses in the world. He's got a great eclipse site, and you can get all the information concerning weather prospects from his eclipse site. So that's just answering a couple of the questions. I don't want to overstay my welcome because I know that there's another talk.
Okay, thank you very much, Michael, once again, and we'll have you back with hopefully some positive results after the April eclipse.
Well, we certainly hope so, and I'll simply say have a happy holiday season to everybody.
You too. Thank you.
All right, bye-bye.
Bye-bye. All right, our next speaker is Norm McCall, the construction of SkyThrall Urban Observatory. Take it away, Norm.
Okay, my name is obviously Norm McCall. Just a little history on myself. I joined the Astronomical Society London Center in 2011, and in 2014 I bought my first telescope at age 60, and then I built this observatory in 2017. And after 2 years of trial and error, I finally got my first live view setup working in February of 2020. So this is when I started, and this is the little logo I have for my observatory. So the first question you might want to ask is, why would you want to build a deep sky observatory? Well, an astronomical observatory located in an urban environment, what is it? It's an astronomical observatory located in an urban environment in which city light interferes and prevents visual observing. Therefore, an urban observatory uses a large aperture telescope to capture a lot of light, a high-performance motorized go-to mount capable of precision computer guiding to accurately track objects at high magnification, specialty resolution, high-resolution thermally cooled astronomy cameras capable of capturing long exposure images, and computer software designed to capture deep sky images in real time for display in a 4K monitor. And there's a picture here on the right showing my setup when it was working at night. So starting off this project, you have to decide on what are your design considerations. So the main factors in building my observatory include the following considerations. Budget, how much am I prepared to spend? And what options are available given my budget? And then the next thing is, what are my needs? So for me, it was to be used for visual and for astrophotography, and both. So those are questions you would ask yourself. And then you've got your backyard considerations, like how much space is available and where to locate the observatory in your backyard given skyline considerations. Next, you move on to what are the design criteria. Well, my design criteria included a budgetary estimate, cost estimate of about $5,000. An observatory suitable for both visual and astrophotography. I wanted a pier mounted scope, polar aligned and ready to go. I wanted a shed with a warm room capable to enable use of the facility in cold winter nights. And I wanted a secure and dry environment for secure storage of astronomy equipment. And I wanted it to be vermin-free and not susceptible to moisture or mold buildup. And I wanted to have space for up to 2 or 3 if I have some friends come over. And the shed size could be no larger than 8 by 8 feet due to limited space available in my backyard. And I also wanted to have an innocuous appearance to avoid attracting vandals. And I was going to have hardwired AC power with a dual Ethernet connection into the house. I wasn't going to depend on Wi-Fi. Okay, so my design options include a dome roof like a SkyPod brand observatory, a traditional roll off the roof design, or there's also the small storage shed with a scope mounted on a rollout dolly, or a roll-off shed with a fixed pier and a mounted scope. So let's consider each of these options here. So you start with the SkyPod design option, which for those unfamiliar, looks something like this. They come in various sizes. So what's the issue? Well, one of the first issue is cost. You've got complications in rotating the roof. Either you do it manually or you do it electronically, which increases the cost, electrically driven. It's got a very large footprint, and it has appearance that could attract, in my opinion, vandalism. And in my view, it's susceptible to rain leakage in the ones that I've observed, with moisture condensation and potentially vermin issues. And there's no way to incorporate a warm room. The next option was a traditional roll-off-the-roof design option. And they look something like this, where the roof rolls off of the shed. And you can have a warm-up room or a heated room inside of that, but it starts to make it bigger. This is a traditional design option for do-it-yourself built observatories. The estimated footprint, unfortunately, is 14 by 8 with the addition of a warm-up room. The total length of everything becomes 16 feet, including the track, which is a lot of real estate, and up to 30% of my backyard. And if built with cedar, it could be very expensive. And another option is as I mentioned earlier, is the rollout dolly design option. This is typically used as a small storage shed with limited space in your backyard. And you also have a lightweight scope mounted on a rollout dolly. And unfortunately, it requires the user to polar align the scope for each use. The stability of the scope on the cart is questionable, especially if it's a heavier scope. And it requires a cement pad to prevent the ground from heaving due to frost. If you want to roll it out over an uneven surface, it's kind of a problem. So let's consider the roll-off shed design options. And this is the one here, where you roll the shed off of the telescope. You'll notice in the picture, you notice in the picture, the shed is sitting on a track mounted on a cement slab. So it has a fixed pier, which I like, with a roll-off shed. The question is how to design a low friction and maintenance-free track. Oops, so it's happening. There we go. And then the question is how to support the front of the shed with the roll-off pier. If there's a floor in here, there's an issue of how do you provide this to open up and allow the scope to come out. You'll see that in other pictures shortly. It does offer a fixed pier and a permanently aligned scope, which is good. It provides a warm room for cold weather use. And this is the best design fit for my design criteria. So here's some examples of roll-off sheds, and this is some of the pictures I captured online, or I found online. There's this design here, and I'm talking here about the floor opening and how do you support this. In my opinion, I don't know how this is supported, although it seems to be supported with bolts mechanism, and but it is an issue and has to be resolved. This is another example. In this case, they just left the opening open for where the shed rolls on. There's this kind of a design, which is a mini design. And in this one here, the shed is sitting on caster wheels that can roll off. It's not going to work very good in the wintertime. And this one here, I'm not too sure. I think this is the one that folds over. I'm not too sure. And this one here is something you just dismantle and move it out of the way. Okay, so my observatory design selection was the Vision 8x7 vinyl storage shed, which is sold in Toronto. And I went there and picked it up myself as a so-called second, which was not a second. It was brand new. There was no deficiencies. It's just how they sell it cheaper directly to the consumer. So the roll-off shed is mounted. The thing I liked about it, by the way, is it's also a 2-inch thick material. So it's kind of insulated for the winter. So the roll-off shed is mounted on a V-groove track. And it is sized and with adequate space for the scope, the computer, and for accessories, shelving. It's a good quality Vision 2 extruded shed. I'm going to design it with an insulated wooden floor, a pier mounted in a aligned scope, and it will be heated for winter use. And it is moisture proof and vermin proof. So you start off with the design of the track, and you see the picture of it here. That is the track I had custom welded up for me. First of all, I estimated the weight of the shed between 800 and 1,000 pounds. That is with people inside of it. You know, that was the design criteria. All right. So the design track options, before I had made the decision to build it this way, one consideration was nylon wheels. Unfortunately, they're susceptible to dirt, rocks, and wear. Rubber wheels may split and require maintenance. And if you use a U-shaped track laid on the ground, it will get filled with dirt and have snow buildup. So my solution was this V-grooved steel wheels on a right-angle stainless steel track. And the reason I chose stainless steel is because steel rusts and requires maintenance. Aluminum is susceptible to pitting from sand and rocks that do get on it. And I used 1.25" stainless steel angle bracket welded to a flat bar, as you see in the picture, and it's maintenance free. So this is how I started construction. It was very hot in the summertime, and I had to dig these holes manually in lovely clay, a lot of it when you dig further down, but this was how I laid it out in my backyard. Now the pier base, I came up with an interesting issue. The hole could only be 42 inches deep, and that was because there was underground, there was the remains of a buried pool, concrete from a pool that we buried. And so therefore the solution for that was I held the pier in place with rebar bonded into the base concrete so that the pier would not shift, move, or crack off that surface. The pier base will use a 14-inch diameter sonotube. And this here is the depiction of the pier, which is here, and the sonotubes. There's 8 of them in total, and I can't remember how thick the diameter. I think those are 12-inch in diameter. All right, and eventually this here is after I poured it and put down the tracks. Oh, it's 10-inch diameter sonotubes for each track. Okay, the wheels sit directly above the sonotubes on the ground so that they don't bend the track if they're sitting there for an extended period of time. The track is adjustable by screws underneath, so if there's any settling or any issues, I can adjust it for level. It's using Western cedar runners to resist rot, ants, bugs, etc. I'm hoping that will ensure a long life as compared to pressurized wood in contact with moisture, which will hardly last a few seasons. This is a close-up picture of the wheels on the stainless steel bracket and how they were mounted to the side of the floor. So the floor construction, this here is made of pressurized wood, pressure treated wood, I should say. All of it is pressure treated plywood, etc. 3/4-inch plywood top and bottom, 2x6 floor joists, and the side joists here on each side are reinforced with leftover plywood. The floor is insulated to keep it nice and warm and you're not freezing your feet off on a cold surface. I use heavy-duty 3-inch torque screws and lags to ensure, you can see them here on the side, right here, lagging things together. All right, the electrical wiring is buried in the structure. And I use 2x8 joists on the side. And then I cover the floor with plywood. And the method I used when I'm standing in here to hold this from falling is I use support beams that go up to a crossover header. So these 2x4s here hold the floor at the front when this is cut out, and they distribute the weight to headers that rest on the side posts over here. I hope that makes sense. Okay, it's tongue and groove wood. And what else did I do? Okay, so the shed foundation is as shown here. The front entrance is cut out, as I mentioned to you, and these are the supports that hold up the front when I'm walking in and out. All right. Okay. The pier is 8 5/8 inch diameter, and it's 32-inch tall, made of steel, and I bought it from SkyPod. And it's mounted on a 14-inch fiber impregnated concrete base. And the pier is removable at the top. You can change this plate if you need to change your mount. So I have done that, and I bought a new plate to be compatible with a new mount. And the pier itself is filled with sand to deaden any vibrations. And I did remember to bolt it down. It's just sitting in place right there. Okay, so first light, August 2017. This is the day I had a party, and it was first light. That was my first scope that I had at the time. And that was a little celebration. You can see that the electrical wiring wasn't yet working. To connect the wires into the shed, I bring the wire out in the ground over here, and there's a flexible conduit that goes up into the shed. So I can roll it out, and there's 2 pipes holding electrical wires and the network connection. And this here is what I call first sunrise over SkyThrall. All right. So this is a picture of it in use. You can see I've got a bench here and the scope wired up with a camera. And at this time, these wires this is the USB wire. I had a problem, which was that the pipe that I'd chosen to connect back of the USB cables was too small. And so I end up having to run the wires in and out each time on the ground. So that was one of those little do it right next time. So what's the advantage? It's a great time saver. I can open that thing up in 10 minutes or so, or close it down in 10 minutes if the clouds roll in. It's a double thick wall design, so there's no condensation whatsoever in the winter, and it helps minimize overheating by sun's rays in the summertime. It's easy to open when the door open when friends come over to visit. The patio stones underneath provide a clean, dirt-free walking surface. Okay, it's totally dry, weatherproof, and vermin-free enclosure. I constructed something like an apron that fits around the telescope when the door is closed, and that keeps any animals from climbing in and making a lovely home in a warm place. There is no water or moisture condensation issues, and the insulated floor eliminates any dampness issues associated with a concrete floor. And there's adequate space to store accessories. And the computer is set up and ready to go at any time. And the equipment is secured from vandalism. So these are just some of the things, pictures of inside the observatory. I've got red lights on the ceiling. I've got a Windows 10 Pro. And the reason I use 10 Pro is because it allows remote desktop. It's got a hardwired Ethernet connection into the house, and got a bunch of 4-watt red lights on the ceiling. And these are the computers, and I got storage shelves there. There's drawers, I should say, and shelves to hold stuff. And that's how things are packed. And this was the little mechanism I used here. That little box I built in that keeps any animals from climbing in the hole and finding a nice place to live. And I got a storage rack here like so. And I run there's my 12-volt battery running all the time for the system. Conclusion? What's the conclusion? Okay, it took an estimated 120 hours of work to complete the observatory. The finished cost was approximately $6,500. The heated room with the insulated floor provides a great work environment. The 8x7 shed size is perfect for size. Areas to improve, I would recommend, I only used 3/4 inch PVC. I should have used 1 inch. I would use in a future design 3-inch diameter V-groove wheels instead of 2¼ inch. It would make it rolling the shed off a bit easier with snow and ice. And I would recommend a 200 CFM or larger exhaust fan in the summertime, just to help keep the temperature down. And if you have any questions, you can contact me here.
Thank you very much, Norm. Enjoyed your presentation. I have a similar make shed observatory, but I converted it to a roll-off.
Okay.
I did a presentation a long time ago about it. Do we have any questions for Norm?
Yes, we do. First, let me start with a comment from Guy Yanez. Maybe we should also consider local regulations and not bothering neighbors unless invite them over. I tend to agree. But he also follows that up with a question. What grease should we use on those rails, if any? And Frank Dempsey essentially repeats the question with, should grease be used with the wheels?
Well, yeah, that's a good question. You know, the thing is, I bought these wheels online from eBay or somehow from China, and I opened them up to grease them. So yes, so the answer is I use grease to grease them, and I found that the seal bearings were pre-used. and the grease in there was black and dry and hard. So they were selling a used bearing in the wheel, and they weren't expecting people to look inside. So I had to go out and buy replacement bearings that are sealed, and I just packed them with grease.
Leo to CAF says, looks a bit like the oil sheds that used to be available. Where did you buy the shed?
You can buy this at Home Depot, or just look up Vision Systems or whatever. They're in Toronto and Scarborough. It's not Markham. I can't remember which part of Toronto. Near the airport, if I recall, but it's hard to remember. Just look up Vision. They sell that shed at Home Depot, but they sell it for $1,200, and I got it for $900 or something.
That's all the questions.
All right.
Okay, thanks again, Norm.
You're welcome.
Our next speaker is Arushi Nath, and she'll talk to us about open source photometry algorithms.
Hi, everyone. It's so great to be presenting here today. My name's Arushi, and I'm a grade 9 student from here in Toronto. And today I'll be talking about how I created algorithms in Python to look at exoplanetary systems. But first, a bit of background. For the past couple years, I've been really interested in planetary defense. In particular, last year, I've been working on creating algorithms that determine the physical properties of asteroids, like how fast they rotate, their size, and so forth. And last year, especially 2022, the Didymos was a very interesting asteroid because it had just been hit by NASA's DART mission with the goal of testing the kinetic impactor method of deflecting an asteroid. So this had provided me with the perfect opportunity to apply my algorithm to determine the physical properties of this binary asteroid Didymos and see how it changed after the impact. And this project was very successful, and I was able to measure several physical properties of the asteroid, like its absolute magnitude, its rotation period, the orbital period of the moonlet, and its size. And this was really fascinating for me. And it was amazing to have my project win the top award in Canada. And in addition, I got to present my project globally at an international science fair, where my project got to win the second core prize. But honestly, I think the best prize here was actually winning the 2023 Youth Astronomers or Young Astronomers Award from the Royal Astronomical Society of Canada. So I would like to say a big thank you to RASC for providing me with this award. And now that I've done this project, I wanted to apply these algorithms that I created to go from asteroids to exoplanetary systems. In particular, I was very interested in exoplanets which follow the transit method. This means that when the planet goes in front of its host star, you will be able to observe a dip in the light coming from the star as the planet blocks some of it. This creates a dip in the brightness. And by observing how much this dip was created, you can see the ratio of the radius of the planet and the star, which can lead you to find the size of the planet itself. But it gets more interesting because these exoplanets also have atmospheres. And these atmospheres react differently in different wavelengths. For some wavelengths, it's absorbed light, and in some wavelengths, it reflects light. So by measuring these exoplanetary transits in different wavelengths or different filters, you should be able to observe different dips in brightness. And this is actually what many space telescopes are already doing. For example, NASA's James Webb Space Telescope and the upcoming Ariel telescope from the European Space Agency, which is launching in 2029. And these telescopes have these very high precision spectrograms, which are going to observe these exoplanetary systems. But time on these big telescopes are very limited, which means that when these telescopes are observing an exoplanet, we have to make sure that this is the best possible use of our time, which means we need to know exactly when the transit of the exoplanet starts and when the transit of the exoplanet finishes. But some of these transits are still not accurately known today. This could be because their periods are very long. For example, the exoplanet takes over a year to orbit its host star. Or simply, not enough observations of that part of the sky has been taken. So, to improve the ephemerides of transit, we heavily rely on citizen scientists. And I wanted to help with this. So I sent a few robotic telescope proposals to different observatories around the world. For example, the Bergafne Observatory in Canada, as well as a few others around the globe. These telescopes don't need to be big. Actually, the smallest telescope that I used was only 6 inches from NASA's Micro Observatory. In addition, I even used my own telescope to set up a few observations. So if you've seen my past presentations on asteroid photometry, you'll notice that some parts of the methodology are quite similar. For example, the first part is finding all known stars in the image. To do this, I used European Space Agency's Gaia database. This allowed me to find all of the known stars in my field of view. I then centrated these objects in my image using simple mathematical formulas. But now I wanted to actually find the brightness of the exoplanet and see how it changed over time. So to do this, I created apertures of different sizes around the exoplanet. I created an inner aperture, and this was to measure the brightness of the exoplanet itself, as well as an outer annulus to measure the background noise. Subtracting the two would give me the pixel brightness of the asteroid. Finding the right size of the aperture was complex because you didn't want it to be too big or would contain too much background noise. And you didn't want it to be too small either, otherwise it wouldn't contain the full object. So analysis and modulo to find the right size. Next, comparison stars. Because exoplanet transits are long, which means observing conditions will change during this time. So to account for these, I used comparison stars to benchmark the brightness. These comparison stars couldn't just be any stars. They had to follow 3 main parameters. First, they had to have a similar brightness to the target star. Second, they had to have a similar color to the target star. These made sure that we were measuring stars under the same parameters. And finally, the stars used as comparison stars could not be variable, and this is essential because otherwise these stars would have fluctuating brightnesses and ruin everything. So then, by measuring the brightness of these comparison stars in the image, I was able to apply these to the target star, in this case, the exoplanet. And after this, I was able to get some outputs. I was able to create the light curves of several different exoplanetary systems. For example, TRES-3b and the WASP-12b. And an observation isn't complete unless you know it's accurate. And my results were able to get validated by the ExoClock initiative, which is from the Ariel space mission. And I was able to submit my observations, and they were accepted, and they're now part of this global database. And this project is far from over. I've plans to continue building up upon my photometry algorithm, and then perhaps even try to use ground-based telescopes to observe these exoplanets in different wavelengths to see if I can measure any differences in the transit depths. So with that, thank you very much.
Thank you very much, Arushi. More excellent work coming from you. Keep it up.
Thank you.
Do we have any questions for Arushi?
We have a comment and a question from me. From Guy Yanis says that this young girl is amazing. People like her will contribute to a better planet to live on. Congrats. And my question is, while you were processing your data, would you happen to have come across any unknown variable stars?
Yeah, that's a great question. And while so far, no, that's definitely a possibility, especially because you're observing the same part of the sky for a very long period, which means that if there is a variable star, then it'll definitely come out. So possibly after I use my algorithm on many different exoplanetary systems, possibly one of the comparison stars I use might be faulty, and looking into it, it could be a variable star, but not so far.
And may I ask, as I've asked in the past, are you publishing any of this in a Jupyter notebook or related?
Oh, definitely. Once I expand this algorithm, I will definitely be posting it on my GitHub account as usual.
Fantastic, thank you. And that's all the
Great.
questions.
Thank you so much.
Thank you, Arushi. All right, so that concludes the speakers lineup for this evening. We'll go to Tom Luton with the announcements for this evening.
All right. Thank you very much, Paul, and thank you very much to all of our wonderful speakers. Good evening, everybody. My name is Tom Luton. I'm the president of the Toronto Centre of the Royal Astronomical Society of Canada, and I'm speaking to you from Cobourg, Ontario. So let's get into the announcements. So we've got two types of meetings here for the Toronto Centre. You've just seen one of our recreational astronomy nights, and then normally we'd be having a speakers night in 2 weeks, but that's on hold because of the holiday season. If you are here for the first time watching us live on YouTube, please say hello in the chat. Enter some questions for the presenters as others have already done. If you're a new member of the Toronto Centre, please introduce yourself. And if you're coming to us from far outside the Toronto area, please let us know where you're coming from. So our next recreational astronomy night will be the 3rd of January, 7:30 p.m. in person at the Ontario Science Centre and online. Andy Beaton will be talking about the sky this month. Ed Trace will be talking about the sky in the year 13372 and other things to mostly look forward to. And Benjamin Law will be giving us a talk on astrophotography. The exact title is still TBA, to be announced. As I said, you can watch this live right here on YouTube. Our speakers nights, like I just said, are postponed until because of the holidays, and our next speaker will be in late January. Now, as Paul mentioned earlier, we've had to reschedule the annual meeting. Normally, this would have happened immediately following this recreational astronomy night. We would have actually started the meeting almost an hour ago. We would have had a shorter number of presentations. What happened is that a senior member of the finance committee suffered a serious eye injury and was knocked out of commission for a while. He's recovered and everything is looking fine. He's back to work, but the timing of this thing was such that it completely threw our schedule out the window, and so we had to move things around. Anyway, so the annual meeting will take place in 2 weeks at 7:30 p.m. on Wednesday, the 20th of December. The agenda, last year's minutes, and the slate of council candidates are on our website. You must register for the meeting no later than 12 midnight on the 18th of December. If you did not receive an invitation and are a member in good standing of the Toronto Centre, please contact myself at president@raskto.ca immediately. Now, the call for additional nominations to join council closes tonight. A member must be in good standing, and the nomination form requires signatures of 2 members. The deadline is midnight tonight. So you've got a little less than 3 hours to get the paperwork in. You drop a line to our secretary@raskto.ca. So coming up, we've got some solar observing going on at the Ontario Science Centre. This is our rain date. Last weekend was a little inclement. So on Saturday, the December 9th at 10 a.m. 12 p.m. to noon, RASC volunteers will be setting up filtered telescopes in the plaza area of the Science Center and offering guests and visitors direct views of solar phenomenon, including sunspots and prominences. This is a weather-dependent event. Please check our website for a go or no-go call prior to attending. Now, I am pleased to announce that the RASC Toronto Centre Gold Medal has a recipient for York University has been announced. The gold medal of the RAS Toronto Center is awarded to the top graduating astronomy major or double major with a cumulative GPA greater than or equal to 7.5, who satisfied the requirements of a 120 credit hours Bachelor of Science program independently in the Department of Physics and Astronomy at York University and the Department of Astronomy and Astrophysics at the University of Toronto. Ladies and gentlemen, the 2022-2023 York University recipient is Darren Singh, and please join me in congratulating him on his remarkable achievement. We will be getting Darren's medal out as soon as we can. Just a heads up, there will be a Toronto Centre Council meeting on the 13th of December at 7:30 p.m. Members are welcome to attend. Please email myself at president@rasto.ca for details and link to the meeting. The weather has started to turn. We've had some snow, we've had some ice. So access to the CAO is a little iffy at the moment. Operations at the CAO are largely back to pre-pandemic conditions, but with a few exceptions. We are currently operating with a maximum of 2 unrelated persons per bedroom who mutually agree to share said room, and masking in common areas is encouraged, but the preferences of the people involved, or the people at the CAO, will be respected. We resumed public outreach events throughout the summer with supervised weekends. If you're interested in using the CAO, please read our bookings page for details and especially all guidelines. Just a few blurbs about some of the jobs that we're trying to fill. We're looking for a chief editor for our Scope newsletter. If you like to edit and write, our Scope newsletter is a bi-monthly publication that reaches every Toronto Centre member. Please reach the volunteer coordinator or drop an email at the volunteer@rasto.ca email address. And we're also looking for a volunteer committee chair, a marketing committee chair. EPO is always looking for additional committee members, especially online presenters and telescope camera operators. Reminder that for all of our volunteer positions, you first must be a member of the Toronto Centre to volunteer. Drop myself a line at president@rasto.ca. Just a brief reminder, RASC membership renewal season. You can renew or sign up online at secure.rask.ca. Gift memberships are available. Contact the national office at mempub@rask.ca for more details. And with that, I'd like to wish you all a very pleasant evening. Thank you very much for joining us. Please follow us on all the forms of social media that we've got listed here. If you've liked what you saw watching live on YouTube, please like and subscribe, hit the notification bell. Be safe, keep looking up. Good night, everybody.